This is the first time something like that is observed, where there is a glow ahead of the object towards the sun.
Astronomers are tracking a newly spotted visitor to our solar system.
NASA has confirmed that the interstellar object 3Y Atlas is on course to make a close approach to Mars, a revelation that has already ignited both scientific and public curiosity. This marks only the third recognized interstellar visitor ever detected in our solar system, following the enigmatic Oumuamua and the spectacular comet 2I/Borisov. The fact that such a body will now come near one of our planetary neighbors places the astronomical community in a rare position. We will be able to observe an object forged beyond the solar system as it interacts with a planet that has long been the focus of exploration. The announcement has set the stage for one of the most anticipated observation campaigns in recent history, not only because of the rarity of interstellar objects, but also because the trajectory presents a unique chance to study planetary and cometary dynamics in an interplanetary setting. Before we start, smash the like and subscribe buttons for more updates. The approach of 3I Atlas toward Mars offers a perspective unlike any we have had before. Previous interstellar objects pass through with fleeting visibility and without significant planetary interactions. But now, Mars provides an observational anchor point. The red planet is orbited by a fleet of spacecraft, rovers, and landers, many of which can be directed to record data during the object's pass. NASA's announcement emphasizes this opportunity, pointing out that the combination of orbital and surface-based observation platforms effectively transforms Mars into a forward base for studying an interstellar traveler. Unlike from Earth, where observations are limited by atmospheric interference and timing, spacecraft circling Mars can observe without such constraints, giving humanity an unprecedented lens into a world from another star system. The scientific implications of this close pass are vast. Interstellar objects are not bound by the processes that shaped our solar system. They carry in their composition, trajectory, and behavior the histories of entirely different star systems and possibly even different types of stellar evolution. By observing 3I Atlas as it nears Mars, scientists hope to collect data on its physical makeup, shedding light on the conditions of its home system. Questions abound. Is it primarily icy, like a comet, or rocky, like an asteroid? Does it shed material as it is warmed by the sun, leaving a tail that resembles comets we are familiar with? Or does it remain oddly inert, hinting at processes unlike those we know? Each answer contributes not only to planetary science, but to the broader quest of understanding how solar systems form and evolve. Mars itself stands to benefit from this encounter in subtle ways. Its thin atmosphere and lack of protective magnetic field make it sensitive to incoming cosmic material. While 3I Atlas is not expected to collide with Mars, its proximity could provide insights into how interstellar particles behave in a Martian environment. Dust and fragments released from the object could potentially interact with the planet's atmosphere, even if briefly, giving researchers the ability to measure the effect of interstellar debris on a terrestrial planet. Such data have implications for planetary defense, and for understanding how life-essential compounds might be seeded on planets through cosmic encounters. Equally engaging is the timing of this event within the history of exploration. Mars is at the forefront of human ambition for interplanetary settlement, with multiple space agencies and private companies designing missions to put humans on its surface. Any interstellar event connected to the planet adds a symbolic weight. The passing of 3I Atlas is not just an astronomical curiosity, it underscores the interconnectedness of planetary science, astrobiology, and human spaceflight. As researchers prepare to analyze the object's passage, the public imagines a future where human eyes might directly witness such an encounter from Martian soil, adding a layer of aspiration to the scientific anticipation. The announcement also underscores the progress humanity has made in its ability to track, classify, and predict the paths of interstellar objects. Oumuamua was discovered late in its trajectory, after it had already passed the closest point to Earth, leaving scientists scrambling with limited data. 2I/Borisov offered a better chance, as it was recognized earlier and followed for months. With 3I Atlas, detection and trajectory mapping have improved enough that we know not only its path, but its planetary interaction in advance. This progression represents a triumph of global astronomical coordination, telescope technology, and data processing. Knowing ahead of time allows researchers to mobilize observational assets around Mars, coordinate Earth-based telescopes, and even consider new methods of study that were impossible during earlier encounters. One of the most striking aspects of 3I Atlas's approach to Mars is the possibility of comparative science. Mars has often been compared to Earth, but in this instance it serves as a comparative environment to Earth's own experiences with interstellar visitors. By studying how the object appears from Mars and contrasting that with Earth-based observations, scientists can better understand the way interstellar objects present themselves under different observational circumstances. The dual vantage point offers an almost stereoscopic view of the object's structure, outgassing behavior, and trajectory. In turn, this refines the models used to predict how such bodies behave as they move through planetary systems. Astrobiology also finds a stake in this moment. Interstellar objects have long been hypothesized as potential carriers of organic material between star systems, a concept often referred to as panspermia. While no one expects 3I Atlas to seed life on Mars, the materials it carries could be chemically analyzed to assess their potential role in such cosmic transport. If it exhibits unusual organic signatures, this would fuel speculation and study on how life's building blocks might travel through the galaxy. Even a negative result, showing that it is barren and lacking in such compounds, adds an important data point to the debate. Mars becomes the laboratory in which these theories are tested, however indirectly, and the results will echo into the broader questions of life's origins. The practical challenges of capturing data from 3I Atlas highlight the complexity of interplanetary observation. Mars rovers like Perseverance and Curiosity are not designed to track distant objects in the sky, but orbiters such as MAVEN and Mars Reconnaissance Orbiter have the instruments capable of capturing spectroscopic data and high-resolution imagery. Coordination between these missions will be essential. NASA's announcement makes clear that planning has already begun to determine what instruments can be tasked, how much time can be devoted, and how to optimize the scientific yield. The fact that these discussions are taking place now ahead of the pass demonstrates the maturity of Mars exploration infrastructure, which has evolved into a multifaceted observatory as well as a research station. The implications for future exploration extend beyond Mars. The knowledge gained from observing 3I Atlas will feed into preparation for possible interception missions of interstellar objects. Already, mission concepts exist to launch probes that can rendezvous with such visitors, capturing data up close or even sampling material directly. The passage near Mars offers a rehearsal of sorts: how to coordinate multiple observational platforms, how to maximize data in a short time frame, and how to integrate planetary-based assets into interstellar science. Lessons learned here may someday enable humanity to physically reach out to interstellar messengers rather than simply watch them pass by. Beyond the scientific and technical aspects, the cultural resonance of an interstellar visitor approaching Mars cannot be overlooked. Humanity has long looked to the stars and wondered about its place in the cosmos. Interstellar objects embody that connection in tangible form. They are pieces of other solar systems, fragments of distant worlds, wandering through our neighborhood. Their arrival sparks imagination in ways few astronomical phenomena do, partly because they are both foreign and familiar. With Mars involved, the narrative deepens. This is not just our solar system being visited, but our future frontier receiving a guest from beyond. The symbolic weight of that moment will ripple through public imagination, space policy, and the ongoing narrative of exploration. As the date of closest approach nears, attention will turn to the specific details of 3I Atlas. Its brightness, rotation, and spectral features will be tracked meticulously, each measurement adding to the growing understanding of interstellar material. Teams across the globe will point telescopes toward the object, coordinating with the Mars missions to create a mosaic of data. The anticipation mirrors that of a rare eclipse or comet, except with the added knowledge that this is not a recurring visitor, but a once-in-history event. 3. I-Atlas will never return. It is on a one-way trajectory through the solar system, its origin likely light years away, and once it departs, it will not pass near again. That fleetingness adds urgency and poignancy to the scientific mission. For the scientists involved, this represents both a challenge and a privilege. The fleeting nature of interstellar encounters means that every piece of data counts, every observation must be planned and executed with precision. There are no second chances. At the same time, the rarity of the event heightens the sense of wonder and accomplishment. To be among the first humans to record detailed data of an interstellar body near a planet is to participate in a chapter of history that will be remembered for centuries. The results, whether surprising or confirming existing theories, will feed into the textbooks of astronomy, planetary science, and astrophysics. The announcement has also sparked discussions about the philosophical and existential significance of interstellar objects. Some see them as messengers, not in the literal sense, but as reminders of the vast interconnectedness of the galaxy. These fragments remind us that our solar system is not isolated. It is part of a greater galactic ecosystem in which matter moves between stars, carrying stories of creation, destruction, and transformation. 3I Atlas, passing Mars, is a testament to that cosmic flow, a narrative that transcends planetary boundaries and human divisions. Even the mechanics of the object's orbit carry profound meaning. Its hyperbolic trajectory ensures that it will not be captured by the sun's gravity, but will continue onward, passing through the solar system and returning to interstellar space. That path is a reminder of the impermanence of cosmic encounters. Unlike planets and comets that return on predictable orbits, interstellar visitors arrive unannounced and leave forever. They are brief but significant guests, and their rarity makes them all the more valuable to study. Mars, by hosting this passage, becomes part of that story in a way Earth never has before. In the months leading up to the close pass, excitement will only build. Astronomical societies, space agencies, and even amateur observers will track its progress. Mars-based assets will prepare their instruments, while Earth-based telescopes refine the trajectory. This shared endeavor represents one of those rare instances where the entire astronomical community unites around a singular event, a collective effort to capture the essence of a fleeting cosmic phenomenon. The legacy of that unity will be a body of data and a sense of connection that reaches far beyond the event itself. NASA's revelation that 3I Atlas is on its way past Mars is more than just an astronomical update. It is a moment that encapsulates the progress of science, the thrill of discovery, and the timeless human desire to connect with the cosmos. As we await the close pass, we stand at the intersection of planetary exploration and interstellar science, ready to witness a cosmic encounter that bridges worlds. Mars, with its silent deserts and robotic emissaries, will play host to a visitor from another star. And in doing so, it will remind humanity of its place in a galaxy teeming with mystery, movement, and meaning. The path of 3I Atlas across the solar system toward Mars places us in a privileged position as observers of cosmic history in motion. Each interstellar object that wanders into our neighborhood carries within it the fingerprints of alien worlds, worlds that lie far beyond the reach of our most powerful telescopes. Now, with Mars as the stage, humanity can study an emissary of the galaxy in ways never before possible. What makes this particular moment so extraordinary is not only the rarity of such visitors, but the convergence of timing, technology, and the sheer wonder of seeing something so alien come so near to one of our planetary neighbors. Unlike typical comets that loop in and out of our system on elliptical paths, an interstellar traveler is a one-time guest. It arrives uninvited, shaped by forces light years away, and leaves just as suddenly, carried on its hyperbolic path into the void. The data window is narrow, the stakes are high, and the scientific possibilities are virtually endless. The decision by NASA to highlight this passage so prominently underlines the immense importance of what lies ahead. An unprecedented opportunity to peer into another system's past through the material now hurtling toward Mars. The closer 3I Atlas comes, the sharper the questions grow. How was it formed? Did it originate near a dying star, flung out by violent gravitational interactions? Or was it cast into interstellar space during the infancy of its system, swept away in the gravitational dance of forming planets? Each scenario would leave subtle imprints on its structure. A fragment born near a young star might be rich in volatile ices, whereas one expelled by a dense, evolved star system might carry exotic mineral fingerprints. Mars-based observations could unlock clues that would take Earth-based telescopes decades to gather. The involvement of Mars makes this approach uniquely compelling. Mars is no passive participant. It is surrounded by a scientific network capable of observation, a hub of technological instruments ready to be tuned toward the interstellar wanderer. Mars orbiters like MAVEN, with its sensitivity to atmospheric and plasma changes, might detect even faint interactions between the object's dust and the Martian environment. The European Space Agency's Trace Gas Orbiter could examine the chemical signatures left by escaping volatiles. Together, they form a scientific net, ready to catch every particle of evidence 3I Atlas chooses to reveal. The chance to combine Mars-based data with Earth-based telescope observations gives scientists a baseline for triangulation. From Earth, astronomers will see the object framed against distant stars, measuring its trajectory and spectrum. From Mars, they will record it under different conditions, free of atmospheric haze. This dual perspective transforms the event into a three-dimensional laboratory experiment on a cosmic scale. The cross-comparison could resolve long-standing debates about how interstellar objects reflect light, how their spectra differ from solar system bodies, and whether their orbits are influenced by subtle, non-gravitational forces such as asymmetric outgassing. This is more than science. It is also a rehearsal for the future. The growing awareness that interstellar objects are more common than once thought has inspired bold proposals to intercept one with a probe. Yet the logistics of launching a spacecraft fast enough to meet an object hurtling through the solar system are daunting. Studying 3I Atlas near Mars acts as a proof of concept, demonstrating how we might one day coordinate assets across multiple planetary platforms. If Mars can serve as a secondary observatory now, perhaps one day human outposts on its surface could mount rapid response missions to meet such travelers head-on. From an engineering perspective, the event highlights the foresight behind maintaining a diverse suite of instruments across multiple orbits and planetary bodies. The fact that we can even contemplate observing an interstellar object from another world is the product of decades of investment. Instruments designed for atmospheric studies, mineral mapping, and magnetosphere research suddenly find themselves relevant to a completely different frontier. This adaptability is one of the hallmarks of exploration. Tools designed with one purpose often become gateways to unexpected discovery when new phenomena arise. On the cultural stage, 3I Atlas's arrival near Mars resonates with humanity's timeless fascination with visitors from beyond. Ancient civilizations watched the skies for comets and meteors, interpreting them as omens or messages from the gods. Today, with vastly greater knowledge, we see them as fragments of cosmic history, yet the sense of awe remains unchanged. The knowledge that this object was born under alien skies, around a star that may no longer even exist, bridges the gap between myth and science. For the public, the drama of a cosmic traveler passing near a planet we dream of colonizing fuels the imagination in ways no telescope data alone could achieve. The chemistry of 3I Atlas is perhaps the most tantalizing unknown. If it carries compounds rich in carbon or complex organic molecules, it would add weight to theories that interstellar exchange of material is common across the galaxy. This, in turn, feeds into astrobiology's grand question: is life seeded by the cosmos itself, drifting between systems on icy bodies like this one? Mars, with its history of liquid water and ongoing search for biosignatures, becomes a fitting backdrop for this line of inquiry. Even if no biological material exists within 3Y Atlas, its chemical fingerprints could help determine whether the conditions for life elsewhere resemble those of our solar system or diverge into entirely alien pathways. The trajectory of 3I Atlas through the Martian neighborhood also forces astronomers to refine models of interstellar dynamics. Its exact path, its velocity, and its orientation are data points feeding into larger models of galactic motion. Interstellar bodies are not random drifters. They follow the gravitational shaping of the Milky Way itself. By tracking its orbit with extreme precision, scientists can back-calculate its origin region, narrowing down which spiral arm or cluster it may have emerged from. Every refinement brings us closer to mapping the invisible highways of matter that thread through the galaxy, the gravitational currents that carry such fragments from star to star. The symbolism of Mars hosting this passage adds a poetic dimension. Mars has always been a mirror for human ambition, a place where we project our longing for new frontiers. For an interstellar object to pass it now, while humanity edges closer to setting foot on its soil, feels like a convergence of timelines, one cosmic, one human. It is as though the universe itself is reminding us of the greater stage upon which our exploration unfolds. The planets and stars are not isolated destinations, but part of a vast web of exchange, where even alien fragments can find their way into our sightlines. The anticipation surrounding 3I Atlas's approach also reveals the growing sophistication of our scientific culture. No longer do we view interstellar phenomena as curiosities observed by a few specialists. Instead, these events become global conversations, broadcast across social media, streamed from observatories, and woven into educational outreach. Children will grow up knowing that during their lifetime, humanity watched a piece of another star system glide past Mars. Such events are markers of collective memory, shared milestones in the story of discovery. For planetary defense experts, 3I Atlas's approach carries a different lesson. While it poses no threat, its unpredictable nature underscores the importance of monitoring the skies for high-velocity objects. Interstellar bodies, by definition, are faster and less predictable than homegrown asteroids or comets. Observing their behavior provides crucial training for what humanity might face if one ever did present a risk. Understanding their structure, how they break apart, and how they interact with planetary environments all feed into strategies that may someday protect Earth or Mars from an unwelcome encounter. The interstellar object also shines a light on the broader cosmic cycle of matter. Stars form, planets coalesce, and gravitational interactions fling fragments outward. These fragments wander until they pass through another system, briefly interacting before continuing their endless journey. In this sense, 3I Atlas is part of a universal rhythm, one that reminds us of the continuity between creation and dispersal. Mars, standing as a silent observer, becomes a participant in that rhythm, touched however briefly by the galaxy's vast circulation of material. Some speculate that events like this could inspire new mission concepts tailored specifically for interstellar encounters. Imagine a probe stationed at Mars, built not only to study the planet but also to respond to cosmic passers-by. With its thinner atmosphere and lower gravity, Mars is an ideal launchpad for intercept missions that might chase down such objects. The close pass of 3I Atlas may become the case study that drives such ideas forward, shifting Mars exploration into a dual role as both planetary science and interstellar science hub. The spectacle of 3I Atlas passing Mars is also a reminder of the unity between observation and imagination. Science alone gathers the data, but imagination interprets it, builds the narratives that give meaning to dry numbers. The realization that this icy wanderer has journeyed untold distances, perhaps for millions of years, only to brush by Mars while we have instruments ready to see it, feels like a story scripted on a cosmic scale. It is coincidence, yes, but it is the kind of coincidence that fuels human wonder, making us feel woven into the larger tapestry of the universe. As the event draws closer, simulations of the encounter will fill computer screens in labs around the world. Scientists will model the exact lighting conditions, predict when dust might escape from the object, and time their instruments accordingly. These rehearsals are themselves acts of exploration, anticipations of data yet to come. Each scientist who participates adds a piece to the puzzle, building a collective anticipation that mirrors the build-up to historic launches or landings. The interstellar visitor will not linger. Its speed ensures that the window for observations will be short, measured in weeks or months at most. Yet that brevity is part of its power. Rarity and transience sharpen the focus, demanding that humanity pay attention. Long after it has vanished into the dark, the data and the memory of its passing will remain, shaping theories, inspiring missions, and reminding us that the universe is larger and more dynamic than we often imagine. Perhaps most moving of all is the idea that while we watch 3I Atlas pass Mars, somewhere else in the galaxy, another civilization might be watching one of our comets slip through their system. The galaxy is full of these drifters, carrying stories from one star to the next. By observing them, we participate in a kind of cosmic dialogue, one that spans light years and epochs. 3. I Atlas is not just a piece of rock or ice, it is a messenger of possibility, a fragment of a story larger than ourselves, now intersecting briefly with our own chapter on Mars. The revelation that 3I Atlas is set to pass close to Mars has triggered a wave of anticipation, not just in the scientific community, but also among those who follow the grand narrative of exploration. The excitement does not stem only from the fact that this is the third interstellar object ever recorded entering our solar system, but also from the particular circumstances of its encounter. Mars, with its network of orbiters and rovers, stands ready to act as a host, as though the planet itself has become a research station for the galaxy. To consider how remarkable this is, one must reflect on the alignment of chance and preparation. Humanity has long dreamed of looking outward to the stars for signs of life, new materials, and cosmic neighbors. Now, as if on cue, a fragment from another star system is set to brush near the very planet we have made into our most studied neighbor. The object's approach represents a fusion of planetary science, astronomy, and even galactic archaeology. Every interstellar object is an artifact, a relic cast adrift from its home system during some ancient violent process. By approaching Mars, 3I Atlas transforms from a distant streak of light into something tangible, something that can be studied in detail. Its trajectory, speed, and spectral qualities will be decoded, but beyond the numbers lies the larger question. What story does this traveler tell about the galaxy? Each measurement is more than data. It is a translation of cosmic history into human understanding. One of the most compelling aspects of the event is the chance to examine how interstellar objects interact with planetary environments beyond Earth. Our planet has been the baseline for understanding how comets or asteroids behave as they warm near the sun. But Mars, with its cold deserts and tenuous atmosphere, provides a wholly different canvas. If dust or gases stream off 3I Atlas, they may briefly interact with Mars's thin air, producing subtle atmospheric phenomena detectable by orbiting spacecraft. Instruments designed to monitor Martian dust storms might suddenly capture traces of interstellar chemistry. Such serendipity could expand our understanding of how cosmic materials disperse and settle when they encounter a planet other than Earth. The prospect of learning about 3I Atlas's composition through Mars-based observations brings to the fore the importance of spectroscopy. Every element and compound has its own spectral fingerprint, and when sunlight reflects off an object like 3I Atlas or passes through gases it may release, orbiters can record those patterns. Scientists may soon be poring over graphs of absorption lines, identifying signatures of ices, organics, or minerals unfamiliar in our solar system. The thrill of detecting something never seen before is palpable. It could be a new kind of ice, or an unusual carbon chain molecule, or a mineral structure forged under pressures or temperatures alien to our own star's influence. These findings could reshape assumptions about what kinds of matter populate the Milky Way. The timing of this discovery also resonates with the broader trajectory of space exploration. Humanity has reached a stage where planets are no longer remote lights, but worlds we actively study with fleets of machines. That Mars can serve as a vantage point for observing an interstellar visitor is proof of this maturity. It demonstrates that our expansion into the solar system has practical consequences for cosmic research. Without those orbiters and rovers, this event would be little more than a distant curiosity. Instead, it is a carefully orchestrated scientific campaign, mobilizing multiple worlds in the pursuit of knowledge. The cultural imagination, too, is quickened by such an event. To know that an object from outside the solar system is passing near Mars invites stories of interconnection. Science fiction has long imagined alien messengers crossing interstellar distances, bearing secrets or dangers. While 3I Atlas is no vessel, its symbolism echoes those tales. It is a true messenger, not in words but in matter, carrying the physical record of its birthplace across light years. Artists, writers, and philosophers alike will find inspiration in the idea of Mars, a planet long seen as the next step for humanity, being brushed by a traveler from beyond the sun's reach. There is also the element of scale to consider. The Milky Way is vast beyond imagination, with hundreds of billions of stars and countless planets. For a fragment of that galaxy to find its way here, to be detected and to pass near Mars at a time when humans are actively studying the planet, the odds seem astronomical. This convergence gives weight to the notion that exploration is not merely about reaching outward, but also about being prepared when the universe comes to us. Humanity is learning that cosmic serendipity favors the ready. The study of 3I Atlas may also offer insight into processes that shaped our own origins. It is thought that interstellar bodies may have played a role in delivering key materials to early Earth, perhaps even prebiotic molecules that contributed to the spark of life. By analyzing an interstellar object directly, scientists may test these theories more rigorously than ever before. If compounds central to biochemistry, such as amino acids or nucleobase precursors, are detected, it would strengthen the idea that life's ingredients are widespread and mobile across the galaxy. Such a finding would not prove life exists elsewhere, but it would tilt the probabilities in favor of a universe teeming with potential. The fleeting nature of the encounter adds a layer of urgency and poignancy. Unlike comets bound to the sun, which return after long orbits, 3I Atlas will never return. Its path is a one-time passage, a hyperbolic dash through the solar system. The data must be gathered now meticulously and comprehensively because there will be no second chance. That urgency is part of what makes the event so compelling. The knowledge that we are witnessing something that will never be repeated adds weight to every photon captured, every observation made. As Mars becomes a hub for interstellar observation, one can imagine future missions designed with dual purposes: to study the planet itself and to serve as sentinels for cosmic visitors. A base on Mars could, in theory, launch intercept missions faster than Earth, given the planet's weaker gravity and thinner atmosphere. In this way, 3I Atlas is not only an object of study but a harbinger of future strategies. It reminds us that as we expand into space, we must be prepared to integrate planetary exploration with galactic observation. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on 3I Atlas passing Mars? Surprising discovery or expected event? We want to hear from you. Thank you for watching and see you next time.